In this video, we're going to derive the product to sum and the sum to product identities. So if we look at the trig identity sheet, okay, we've covered all of the fundamental identities. We've covered the sum and difference formulas, the cofunction formulas. We've covered the double angle formulas. And now in this video, we're going to be deriving the product to sum and the sum to product formulas. Okay, what we're going to do is we're going to start with the product to sum identities. And actually, let's come back. So the idea is what we're doing with these trig identities is with product to sum, we've got a product of trig functions. And then we want to convert that to where there's no more product of trig functions anymore. It's strictly sum or difference, right? On the right side of each of these, there's no trig functions being multiplied by another trig function at all, right? It's strictly summing or subtracting. And then with the sum to product, you start with, it's a pure sum or subtraction of certain trig functions, and you convert it to where there's no trig functions being summed or subtracted, only multiplied, sum to product. And so we're going to start with the product to sum. How can we derive these product to sum identities? Okay, so let's bring up the sum and difference formulas, okay? And we can start with cosine here. Let's add the sum formula for cosine and the difference formula for cosine together. Okay, so to add equations, so we can put them vertically on top of one another. Okay, now okay, so now we want to add these two, and we get, okay, cosine of A plus B plus cosine of A minus B is equal to, so minus sine A sine B plus sine A sine B, that goes to 0. And we have cosine A cosine B plus cosine A cosine B, so that's 2 cosine A cosine B. Okay, now let's flip this. Let's put the 2 cosine A cosine B on the left side and then divide both sides by 2. So if we do that, we've got cosine A cosine B is equal to 1/2 times cosine A plus B plus cosine A minus B. And there you go. There is the product to sum identity that involves the product of two cosines. Cosine of one angle times cosine of another angle. You can break that up to where it's just strictly a sum, no products. Okay? Now we can do, if we subtracted these two, and actually let's subtract cosine of A plus B from cosine of A minus B. So that would, I'll rewrite it. That would be, the signs will work out better in this case. A minus B is equal to okay, so subtracting these two, you've got cosine A minus B minus cosine A plus B. Now these subtract out and you get, okay, so now flipping the sides and dividing both sides by 2, you've got sine of A sine of B is equal to 1/2 cosine A minus B minus cosine A plus B. And there we go. Okay, so now let me make some room here. Okay, So now we can do the same process with the sum difference identities for sine. So let's subtract sine of A minus B from sine of A plus B. Okay, so now if we add these two, we've got so let's see, 2 sine of A cosine B. So, all right, so that's sine of A cosine of B is equal to 1/2 okay. Okay, now let's subtract. So we'll subtract sine of A plus B from sine of A minus B. Okay, sine of A plus B. Okay, so we want to subtract these, and then we've got, so sine of A minus B minus sine of A plus B is going to be equal to, so it's going to end up being a negative here. So actually, let's do it the other way. Let's subtract sine of A minus B from sine of A plus B. So that would be, we would have sine of A plus B minus sine of A minus B is equal to, so these two subtract out, but then you're going to have cosine of A sine B minus cosine of A sine of B. So that would be 2, and then we'll say, let's see, let's do cosine A sine B. All right, so therefore cosine A sine B is equal to 1/2 sine of A plus B minus sine of A minus B. All right. There we go. Okay, and there are the 4 product to sum identities. Now, you might ask the question, well, what about tangent and secant, cosecant, and cotangent? Well, okay, if you wanted to get, let's say, tangent of A times tangent of B, well, then you just need to divide sine of A times sine of B by cosine of A times cosine of B, right? You could divide sine A sine B, divide this by this, and you see you get tangent of A times tangent of B. And then if you wanted cotangent of A times cotangent of B, then you take the reciprocal of this, right? This here is equivalent to 1 over tangent A times 1 over tangent B. That's cotangent A times cotangent B. So it's the reciprocal of this. And you could kind of derive any of these with the corresponding tangents or cotangent that way. And, similar idea with secant and cosecant, you just take reciprocals. If you wanted secant of A times secant of B, that's the reciprocal of cosine A times cosine B. If you took the reciprocal of cosine A times sine B, that would be secant of A times cosecant of B. Okay, now the sum to product identities. If we start with, let's start with sine A times cosine B. We're going to use this formula. All right, let's say that U is equal to A plus B. And then let's also say that V is equal to A minus B. Okay? So now from here, we can think about what is U plus V. That's going to be A plus B plus A minus B, which is 2A. Okay, now if we think about what is U minus V, that's going to be A plus B minus A minus B. So that's A plus B minus A plus B. So that's going to be 2B. Okay, so therefore we can solve for A here and get that A is equal to U plus V divided by 2. And we can solve for B here and get that B is equal to U minus V divided by 2. Okay, so now let's substitute A and B into the product to sum identity between sine and cosine. So you've got sine of U plus V divided by 2 times cosine of U minus V divided by 2 is equal to 1/2. Okay, sine of A plus B is just U. Let's write it in terms of U. And then sine of A minus B is just V. Okay, now in the same way that we did previously, let's divide both sides by 2 and flip the sides to where we're going to have sine of U plus sine of V is equal to 2 sine of U plus V divided by 2 times cosine of U minus V divided by 2. And there you go. But we can now, so that there's an identity. Let's just write it like we've with the same variables that we wrote the other ones. So we could just, so U and V are any angle, right? So we can write this as sine of A plus sine of B is equal to 2 sine of A plus B divided by 2 times cosine of A minus B divided by 2. And there we go. Okay, so let's put this here. All right, now we can do this exact same process with the other 3 of the product to sum identity. So we just derived this with sine A times cosine B. Let's take cosine A times sine B. Okay, this exact same substitution. So we'll plug in cosine of U plus V divided by 2 times sine of U minus V divided by 2 is equal to 1/2 sine of A plus B is U minus sine of A minus B is V. Multiply both sides by 2, flip the sides, and I'll just go ahead and write U as A and V as B. So you've got sine of A minus sine of B is equal to 2 cosine of A plus B divided by 2 sine of A minus B divided by 2. There we go. Okay, now let's take this cosine A times cosine B. Okay, so cosine let's see, cosine of A plus B, that's cosine of U plus cosine of V. All right, so now let's replace U with A and V with B and multiply both sides by 2. So cosine of A plus cosine of B is equal to 2 times cosine of A plus B divided by 2 times cosine of A minus B divided by 2. There we go. Okay, now let's do sine of A times sine of B. Okay, so sine of U plus V divided by 2, sine of U minus V divided by 2, cosine of U minus cosine of V. So, okay, we've got cosine of A minus cosine of B is equal to 2 times sine of A plus B divided by 2 times sine of A minus B divided by 2. Okay, and there we go. Here are the product to sum identities, and here are the sum to product.